Today I am going to explain the ICPC balloon problem, a simple yet interesting problem that tests our understanding of strings and basic data structures. We will first understand the problem statement and then see an efficient solution. In an ICPC contest, every time a team solves a problem, they receive one balloon. However, if it is the first time that a particular problem has been solved by any team, they receive one extra bonus balloon. That means first solve of any particular problem, the team will get two balloons, and every later solve of the same problem, the team will get one balloon. Our task is to calculate the total number of balloons distributed based on the given sequence of solved problems. The input begins with the number of test cases. For each test case, we read the length of the string, then we read the string itself. Each character represents a solved problem, and all characters are uppercase English letters from A to Z. For every test case, we simply print one integer, the total number of balloons that are awarded to any particular team. Since the string length is at most 50 and there are only 26 possible problem letters, the constraints are very small, allowing an efficient linear solution. Now, let's understand this with an example. That is A, B, A, C. The first A is new, so the team will get two balloons. Next, the B is also new, so the team will get two balloons. Now, the next two A's that have already appeared, so for each problem, the team will get only one balloon, that is, two balloons in total. Finally, C appears for the first time and the team will get two balloons. Adding up everything together, the total the team will get 8 balloons. We should also think about some special cases. That is, if all the letters are the same, only the first occurrence will get 2 balloons. If every letter is unique, each one gets 2 balloons. A single character always gives 2 balloons because it is its first occurrence. These cases help us to verify that our solution works correctly for every input. Now we have understood the problem. Let's look at an efficient solution. The goal is to identify whether each problem is being solved for the first time or has appeared before. Now, understanding the rules. The rules are very simple. Every solved problem always earns one balloon. If it is the first occurrence of that problem, we add one extra bonus balloon. Therefore, the first occurrence gives two balloons, the repeated occurrences give only one balloon. Our solution uses a hash map, especially an unordered map in C++. The algorithm has two passes. First, we record every character in the map. Second, we traverse the string again to calculate balloons. Since hash map operations are constant time on average, the overall solution is very efficient. Now, for frequency counting, during the first traversal, we count how many times every character appears. For example, in the string A appears twice while B appears once. These values are stored inside the hash map and will help us identify the first occurrences in the next step. Now, in the balloon calculation, we traverse the string again. If the map value for a character is not 0, it means this is the first time we are processing that problem. So we add two balloons and now set its value to 0. If the value is already 0, then the problem has been processed before, so we add only one balloon. This simple logic correctly handles both first and repeated occurrences. Now let's dry run the string A. First A. Since A is new, the total becomes 2. Now B. Since the B is also new, the total becomes 4. Now A. Since we are encountering A for the second time, the number of balloons we get for this second occurrence of A is 1. So our total becomes 5. Therefore, the final answer is 5 balloons, which matches our expected result. Now, for the complexity analysis, we make only two linear passes over the string. Therefore, the time complexity is big O of n. The hashmap stores at most 26 different uppercase letters. So the space complexity is big O of k, where k is less than or equal to 26, which is effectively constant. This makes the solution both simple and optimal for the given constraints. To conclude this problem demonstrates how a simple hash map can efficiently distinguish between first and repeated occurrences. By using the linear traversals, we can achieve an optimal big O of n solution while keeping the implementation straightforward. Thank you. If you found this explanation helpful, please check the description for the complete source code. Feel free to share your suggestions or feedback in the comments. They will help me improve future presentations. Thanks again and have a great day.